Hey everyone, welcome back to CodeMechanic. Ever wondered what happens when you plug that little scanner into your car? What magic is going on inside that OBD2 port? Well, today, we're pulling back the curtain. We're going to demystify OBD2, explaining exactly how these diagnostic scanners work, what all those pins do, and the kind of goldmine of information they can give you about your vehicle. This is the foundation for any DIY mechanic, so stick around. First off, what even is OBD2? It stands for Onboard Diagnostics, version 2. Since 1996, every car sold in the US has been required to have this system. It's like a universal language for cars, allowing a single tool to talk to a Ford, a Toyota, a BMW, you name it. The port itself, that 16-pin connector, usually found under your dashboard, is the gateway to your car's brain, the engine control unit, or ECU. Let's look at the pins. Well, there are 16 of them. You don't need to know every single one. The most important ones are for power, ground, and communication. Different pins use different communication protocols, like CAN or J1850. Think of these protocols as different dialects. Your scanner's job is to figure out which dialect your car speaks and start the conversation. When you plug it in, the scanner powers up and sends out a signal saying, "Hey, is anyone there?" The ECU responds. They agree on a language, and the data starts flowing. It's a digital handshake. So, what data are we talking about? The first thing most people look for are diagnostic trouble codes, or DTC. When your check engine light comes on, the ECU has stored a specific code that points to the problem. For example, a P0420 code often points to a failing catalytic converter. But just getting a code isn't the whole story. It tells you what the system is seeing, but not always why. That's where the real power of a good scanner comes in. This brings us to live data. A good scanner can show you what your car's sensors are reporting in real time. You can watch your engine RPM, coolant temperature, oxygen sensor readings, fuel trim, and so much more. This is crucial for diagnostics. For instance, if you have a rough idle, you could watch the live data from your mass airflow sensor. If the readings are erratic or way off from the manufacturer's specs, you've likely found your culprit. It is like being a doctor and seeing the patient as live vitals instead of just hearing them say, "I feel sick." And finally, there's something called freeze frame data. This is one of the most useful but often overlooked features. When a DTC is triggered and the check engine light comes on, the ECU takes a snapshot of all the important sensor data at that exact moment. It literally freezes the frame. So, if you have an intermittent issue, that's hard to replicate. The freeze frame data shows you the exact engine conditions when the fault occurred. Was the engine hot or cold? Was the car accelerating or idling? This information is like a detective's clue, helping you piece together the puzzle of what went wrong. So, to recap, your OBD2 scanner powers up, establishes communication with your car's ECU, and can then pull up trouble codes, show you live sensor data, and give you a freeze-frame snapshot of when a problem occurred. It's an incredibly powerful tool that turns you from a part swapper into a real diagnostician. Understanding these fundamentals is the first step to saving a ton of money and gaining confidence in fixing your own car. I hope this breakdown helps you understand the magic behind that little OBD2 port. If you found this useful, give this video a thumbs up, and don't forget to subscribe for more deep dives into automotive tech. Let me know in the comments what you want to learn about next. Thanks for watching, and I'll see you in the next one.